Okay, this is problem 5 from chapter 2 in Wald's General Relativity. He wants us to let y1 to yn be smooth vector fields on an n-dimensional manifold M, which form a basis Vp at each point belonging to the manifold. So we're allowed to suppose that the commutator of y alpha and y beta is 0 for all alpha and 0, or for all alpha and beta, and then we want to prove that in a neighborhood of each point belonging to the manifold there exist these coordinates, y1 to yn, such that these capital Y are the coordinate vector fields or partial derivatives. So it gives us this hint that we can use, and we will make use of it. So in an open ball of Rn, the equations df by dx mu equals f mu for the unknown function f have a solution if and only if this relation is true. So we have something from problem 4b that lets us make use of this, and we will go ahead and do that. Now this is one of the problems from this chapter that I think I understand the least, to be honest with you, so if anybody sees the solution, has an issue with it, please let me know in the comments. But otherwise I'm going to have a go. So we start with a chart, phi we'll call it. Oops. And this is mapping from the manifold to what we're going to call U, which is a subset of Rn. And we have associated coordinates x sub n. We're going to define a new chart f from U to Rn with y and the associated coordinates. So that's just like a looking forward thing. So what we actually get from the problem is that these y alpha and y beta have a commutator that is 0. Now if we use the result of problem 3c, this means that the constants c, gamma, alpha, beta also have to be 0. And what this implies then, if we use the result of 4b, so I would suggest doing these other problems first, it implies that we get this relationship. Equals so we're kind of going backwards from what the hint suggested, right? So we're starting with this, a relation of this form, and we're going to say that by the Poincare lemma, this ensures the existence of a function that looks like this. So let's go ahead and write this down. So since we have this relation being true, Poincare lemma ensures the existence of a function, call it y gamma, mapping from U to Rn, such that so really this is the same thing as what's being said here. We're just adding gammas, like this basically. So we can make this assumption provided that U is an open ball. So we're going to make that assumption. We've already said it's a subset of Rn. Okay, and then we also know from previous problems that in general y gamma is just going to be y gamma sigma del gamma. So let's substitute in y gamma sigma from up here. We're going to have del y gamma by del x sigma times del by del y. So this shows that the y sigma are the coordinate vector fields that we're asked to find, and therefore f composed with phi is the desired coordinate system.